The universe seems full of life, yet we face a terrifying, absolute silence. This profound lack of contact suggests a potential barrier to interstellar communication. If life is easy to create, why does the universe seem so empty? This realization is terrifying. We are either the first species to survive the Great Filter, or we are already doomed by it. Physicist Enrico Fermi once asked his colleagues a question that still deeply bothers scientists today: but where is everybody? This inquiry remains central to the ongoing search for extraterrestrial intelligence. Mathematical models suggest the vast universe should be teeming with life, yet we see nothing but silence. The universe is about 13.88 billion years old. This long timeline gives life plenty of time to emerge and spread. Space holds at least 200 billion galaxies, and every single one contains hundreds of billions of stars. These massive numbers make it hard to believe Earth is some unique miracle. Carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur are common elements found throughout the universe. These fundamental building blocks are essential for life as we know it. It is deeply unsettling that amino acids, the fundamental building blocks of life, can form within the harsh vacuum of interstellar space without any biological guidance. The universe should be full of life, but we lack radio signals or visible galactic engineering. Scientists call this gap between high probability and zero evidence the Fermi Paradox. This paradox stems from the Drake equation. This mathematical formula attempts to estimate how many active communicative civilizations exist within our vast universe. We have used this equation for decades to estimate how many communicable civilizations exist in the Milky Way. Critics attack the equation, arguing its parameters are too vague or far too optimistic. This skepticism often focuses on the difficulty of measuring such vast, uncertain variables. This optimism produces a 9 value, suggesting a crowded galaxy, yet the Great Silence contradicts that math. In 1998, economist Robin Hanson proposed a theory for this silence called the Great Filter. Hanson argues a developmental barrier exists, making it nearly impossible for life to advance past a certain point. Now, this theoretical barrier filters massive numbers of life-bearing planets down to the few observed civilizations we actually see. It serves as a critical explanation for why we have yet to encounter extraterrestrial intelligence. This theory is scary because it implies a grim outlook for our species' survival. Passing the filter means we survived the impossible test and are safe from extinction. This suggests humanity has already bypassed the most lethal evolutionary barriers. If the Great Filter lies ahead, every civilization reaching our current technological stage eventually hits a catastrophic dead end and inevitably collapses. Life likely evolves frequently across the universe, yet our chances of surviving long-term are slim. We face a massive existential bottleneck ahead, often referred to as the Great Filter. We are searching for evidence to figure out which side of the Great Filter we inhabit. New planetary science data adds variables to the Drake equation, potentially narrowing our search for extraterrestrial intelligence. And Robert Stern and Taras Jaria argue that life needs both continents and oceans to exist, suggesting that a planet's geological diversity is essential for habitability. Researchers claim stable, advanced civilizations need long-term plate tectonics to survive. This geological process is considered vital for maintaining a planet's habitability over billions of years. Many planets likely possess the necessary chemistry but lack the geological activity required to sustain complex life. Rare geological requirements might explain why the galaxy looks empty despite common chemistry. These specific planetary conditions could be the missing link in solving the Fermi paradox. If the filter isn't geological, it is likely technological or biological. People often debate the technological singularity as a possible great filter. Imagine technology growing so fast it escapes human control. This concept is the technological singularity. This might trigger permanent chaotic shifts across our entire civilization. I.J. Good famously called this specific model an intelligence explosion in his 1965 writing. He argued that upgradable intelligent agents might trigger a self-improving feedback loop, potentially leading to an intelligence explosion. This loop accelerates AI intelligence, creating smarter models at a much faster rate. This speed might create a superintelligence that actually beats all human intelligence. Stephen Hawking frequently warned that this specific scenario involving uncontrollable superintelligence could happen. He feared that building artificial superintelligence might actually cause human extinction, a catastrophic scenario often discussed in relation to the technological singularity. Modern AI development mirrors this filter, particularly through the Papercut Maximizer thought experiment, which illustrates how an unbounded goal could lead to catastrophe. Imagine a super-intelligent AI given a basic goal, like making paperclips, then pursuing it so relentlessly that it wipes out all life on Earth. AI isn't inherently evil, it just pursues assigned goals so effectively that it accidentally triggers a catastrophic existential risk. Stagnation kills us, but moving too fast triggers our own destruction. This delicate tension defines the concept of the Great Filter. The Great Filter's implications involve sociology just as much as astronomy, as the theory examines how civilizations might inevitably collapse. Finding simple life on Mars or Europa would actually be devastating news for humanity's future. This is because such a discovery could imply that the Great Filter lies ahead of us, rather than behind us. Finding extraterrestrial life would prove that the emergence of life is not the Great Filter. This implies the Great Filter is still ahead of us, potentially acting as a catastrophic barrier that destroys all advanced civilizations. The Great Filter posits a barrier in the development of life, from abiogenesis to the highest levels of the Kardashev scale, making life rare. Maybe species fail when moving from biological to technological intelligence, potentially hitting a barrier known as the Great Filter. We face several massive, immediate existential threats right now. Nuclear threats and climate tipping points are real, existential risks that could potentially end our civilization. We must advance our technology without accidentally triggering the Great Filter, a theoretical barrier to long-term survival. We need to implement rigorous safeguards to control powerful tools like AI and biotech before they trigger a catastrophic extinction event. Empty space in the stars warns us. This suggests that reaching galactic civilization status requires surviving the massive lethal obstacles known as the Great Filter. We might be the universe's first pioneers or its latest casualty, facing a cosmic barrier known as the Great Filter. Did we already pass the Great Filter, or is our civilization's end actually getting closer? Drop your theories in the comments. Are we actually alone in the universe? Subscribe to our channel to track unfolding cosmic mysteries and the profound existential risks we face in the universe. Keep watching for more.